So here's where things start to get really tricky. And it's going to be very easy for you to get lost in this second half of chapter 7. The key to learning all this about normal curves is so that we can standardize what's going on in that normal curve. And so essentially, any of these normal curves we can convert into what's called a standard normal probability distribution. A standard normal probability distribution is one particular normal distribution. Gesundheit. So if this is one particular normal distribution, what could I use to describe it? What are the two pieces of information I could use to describe this normal distribution that's a standard normal distribution? What were the two pieces of information that completely described the normal probability distribution curve? Mean and the standard deviation. Very good, Yang. So this particular one is going to have a mean of 0 and a standard deviation of 1. And so now we need to define a new term called a z-value. Z-values are going to be useful in avoiding complicated statistical calculations and using our cheat sheets or our tables in the back of the book. So a z-value is defined as the signed distance. So we're not taking the absolute value of it. That's what this is saying. The signed distance between a selected value designated x and the mean designated mu divided by the standard deviation. And so this z-value relates to the conversion process that we're going to do. So when we have a normal curve of a mean that is mu and a standard deviation that is represented by sigma, then we can convert this to provide a standard normal value by doing this z-value process. So we do z equal to x minus mu divided by sigma. And the results, these z-values, you'll also hear these called z-scores sometimes. So this is a way to standardize the different particular normal distributions into this one standard normal distribution. And that way we can calculate the probabilities in a much faster, cleaner way by using our z-tables. So when we're using our z-tables, they are going to look something like this. So there's going to be a z on the columns, or sorry, for the rows. So we're going to have a z, and we'll just do what the book does. So you pick a z, you pick the first integer and then the first decimal place, the 10th decimal place here for your z. And then you have to go and find the second decimal place. So for instance, just doing a little segment here. So if we ended up getting, in this example here, a z statistic that is equal to 1.302, actually that's not right, 1.32. So we add this 2 to the end of this. So we take this guy, and we boop, add it there. So 1.32, we're going to find this value right here. And so this is going to correspond to a probability of 40.66%. We're going to do some examples of this. It'll be a bit easier. All right, let's stop this video and then we'll do an example.